Has your engine been feeling a little pressure lately? If you're dealing with rough idle, sluggish acceleration, or poor fuel economy, your map sensor might be sending the wrong signals. Don't worry, I'm here to run you through the main diagnostic testing methods you can use to accurately diagnose a map sensor fault. Hi again everyone, welcome to the next instalment of our automotive sensor series. Today we'll be investigating the map sensor. And if you don't know your map from your MAF, don't worry, you're in the right place. Let's break down how this sensor keeps your engine running smoothly and what to check when problems develop. The manifold absolute pressure sensor, or MAP sensor, is a key component in the engine's combustion cycle. It measures the air pressure within the intake manifold so that the engine control module knows exactly how hard the engine is working. The ECU uses this information along with other sensor inputs to calculate optimal fuel injection and ignition timing. It's important to note that not all vehicles have a MAP sensor. Almost all modern fuel-injected vehicles have either a MAP or a MAF, a mass airflow sensor. Both help the ECU determine the proper air-to-fuel ratio for combustion. The key difference is that a MAF measures airflow at the start of the intake pipe, while a MAP measures air pressure further downstream at the intake manifold. Turbocharged and other forced induction engines typically use both sensors to give the ECU more accurate data, as boost causes large and rapid fluctuations in air intake. If you want to know more about the MAF sensor, click on the pop-out banner here to watch our diagnosis video. The MAP sensor detects changes in air pressure within the intake manifold, which fluctuate based on engine load and throttle position. When the throttle is closed, such as during idling or deceleration, manifold pressure is low, creating a high vacuum. Alternatively, when the throttle opens and more air rushes in, manifold pressure rises. The MAP sensor reflects this pressure change through its signal voltage output to the ECU. Most modern MAP sensors use a tiny silicon diaphragm that flexes and relaxes relative to manifold pressure. As manifold pressure increases, the silicon chip inside the MAP sensor flexes accordingly. This changes its electrical resistance, allowing the sensor to output an accurate reading to the ECU. Like many other sensors, the ECU provides a 5-volt reference supply. This powers the sensor's internal circuit and serves as a baseline voltage for the sensor to adjust according to changes in manifold pressure. The sensor feeds this voltage back to the ECU via a signal wire. The ECU also provides the MAP sensor with a ground connection to complete the circuit. As a minimum, you'll find these 3 wires present for all MAP sensors. However, more modern sensors incorporate a 4th wire, responsible for feeding the ECU with an intake air temperature signal. In this video, we will be looking at pull-up monitored 3-wire MAP sensors. But even if you have a 4-wire sensor with integrated IAT, the diagnostic process is mostly the same. Always check your vehicle's wiring diagram before starting any testing just to make sure. When this sensor fails, you can expect everything from poor engine performance to a range of MAP-related fault codes. Like almost everything on our vehicles nowadays, these can be caused by electrical issues like damaged wiring, corroded connectors, internal failure in the sensor, or a faulty ECU. Thankfully though, we've got a few checks you can run through to get to the bottom of this. If you do find that your ECU is the cause of your fault, then don't worry. Send it in to us where our expert techs will remanufacture your unit to eradicate all faults. Click the link on screen now to send your ECU in to us. But for now, let's get into the diagnosis. First and foremost, you should check live map readings with a diagnostic scan tool. You should see steady readings that change promptly with throttle input. If readings are stuck, erratic, or unresponsive, that's a strong indicator of a fault. Unfortunately, MAP sensors can develop issues over time. One of the most common is clogging from carbon buildup, dirt, or oil contamination from the intake system. Before starting any electrical diagnosis, remove the sensor and ensure the tip is clean and clear of any contamination, and clean it if necessary. If it looks okay, then inspect the sensor, its connector and related wiring for any obvious signs of physical damage, corrosion or poor terminal tension. If these all check out okay, then use your vehicle's wiring diagram to identify the correct terminals for each MAP sensor connection. By performing a few simple tests with your multimeter, we can check that the sensor is receiving everything it needs to function correctly. In this video, we're testing a map sensor where the signal wire is monitored by a pull-up resistor. Knowing which type of circuit your sensor is monitored by is crucial to the diagnostic process, as you'll find good voltage readings are different if your sensor utilises a pull-down resistor. Like any circuit, we need to verify that the map sensor is receiving a good ground and power supply from the ECU. To test this, ensure the ignition is off and disconnect the sensor. Turn your ignition back on and, with your multimeter set to volts DC, place the red probe on the 5-volt reference supply terminal at the sensor's connector and the black probe on battery negative. You should expect a good reading of close to 5 volts. Moving your red probe to the sensor's signal terminal, you should find that voltage is being pulled up, again to around 5 volts. Next, check the circuit's ground connection. To do this, place the red probe on battery positive and the black probe at the sensor's ground terminal. Expect to find battery voltage here, which, dependent on the health of your battery, should be around 12.6 volts. If these readings are correct, it means the sensor has a good ground connection and is receiving the correct voltages, so the problem is likely with the map sensor itself. However, if any of these voltage readings aren't present, there is a fault somewhere else in the circuit. When this happens, you'll typically have a stored fault code for either high or low voltage in the map sensor circuit, alongside a generic circuit malfunction code. This is commonly caused by electrical issues such as a short, an open, or high resistance, which could be in the wiring or internal to the ECU. To determine the cause, turn your attention to the ECU's connector. Use your vehicle's wiring diagram to locate the correct terminals for the relevant map sensor connections. Now, we're going to perform the same test as before, but this time back probe the wires at the ECU connector. With your black probe at battery negative and your red probe at the sensor reference supply terminal, expect to find 5 volts. And expect to find 5 volts again at the signal terminal. As before, with your black probe at the ground terminal and red probe on battery positive, expect to find battery voltage of around 12.6 volts. If any of these voltage readings at the ECU's connector are incorrect, the fault lies in the engine ECU itself. However, before condemning the unit, turn the ignition off and disconnect the ECU to inspect its pins and connector for any obvious signs of damage like bent pins or corrosion. If these check out okay, then the fault is with your engine ECU, and you can send your control module into us for a comprehensive test, where we'll be able to tell you conclusively if it's the source of your map sensor problems. Once confirmed, we can rebuild your ECU in just 2 to 3 days. Click the pop-up on screen now to learn how to send it in. If you've verified that the engine control module is outputting the correct voltages, then we need to conduct further investigations depending on whether the readings at the sensor or the ECU signal wire connection are higher or lower than the expected ranges. 2 of the most common symptoms of a map sensor circuit malfunction are the codes P0107 and P0108. Let's start with the first of these annoying codes. P0107 means map sensor circuit voltage low. The ECU is detecting a lower voltage than expected via the signal wire. This is typically being caused by a short to ground or high resistance in the sensor reference circuit. If you found that the ECU is adequately outputting around 5 volts to the sensor reference circuit, but you haven't found this voltage present at the sensor's connector, there is a clear issue in this wire. With both the ignition and engine off, disconnect the sensor reference wire from each connector and switch your multimeter to ohms. Probe either end of the isolated wire. You should expect a good reading of less than 0.5 ohms. A greater reading would indicate high resistance. A reading of OL, or open loop, indicates there is a break somewhere in the wire. To test for short to ground, probe either end of the wire against battery negative. The wire is disconnected, so you should expect to read OL. If you don't, this indicates the sensor reference wire is shorted to ground. If you previously found an abnormal reading at the signal circuit, it's likely that this wire has suffered a similar fate. Presuming your map sensor's signal circuit is monitored by a pull-up resistor, you should expect to find 5 volts at both connectors with the ignition on and engine off. If you found this voltage to be present at the sensor's connector but not at the ECU's, it strongly suggests a wiring fault in the map sensor's signal wire. Here, you'll need to carry out the same test as you've just done for the sensor reference circuit. Switch the ignition off and disconnect the signal wire from both connectors. Probe both ends of the wire with your multimeter set to ohms. Again, OL indicates there's an open on the wire, while an ohms reading greater than 0.5 indicates high resistance. To identify a short to ground, resistance test either end of the wire against battery negative. Any ohms reading indicates the map sensor signal wire has shorted to ground. Now, if your diagnostics are detecting a voltage high code, such as P0108, a similar process is going on, only the ECU is detecting an unusually high signal reading rather than an unusually low one. In this situation, it's likely there's a short to voltage, an open or high resistance in the map sensor signal circuit. With the ignition off, disconnect the ECU connector and remove the signal wire from the terminal. With all of the wires reconnected, plug the connector back into the ECU. Switch the ignition on and probe at the removed terminal end of the wire. As the wire has been disconnected from its pull-up resistor in the ECU, you shouldn't expect to detect any voltage. If you do, this indicates the map sensor's signal wire has shorted to voltage. To isolate the short, set your meter to ohms and test for continuity between each of the ECU's terminals. The terminal that gives you an ohms reading indicates which wire has shorted to the map sensor's signal wire. If this checks out okay, you need to test the signal wire for an open circuit or high resistance, as this could have been preventing the map sensor from pulling the signal voltage to the correct level in response to manifold pressure changes. To test this, switch the engine and ignition off, disconnect both ends of the signal wire from both the sensor connector and the ECU. With your multimeter set to ohms, a reading of OL indicates an open circuit, and an ohms reading greater than 0.5 indicates high resistance. In each case, the wiring will need to be repaired in order to resolve your P0108 fault code. If you have a performance-related map sensor fault code and all the electrical checks showed good readings, then it could be caused by a dirty throttle body. Positioned ahead of the map sensor in the intake system, a carbon-coated throttle plate can restrict airflow. This restriction creates a higher than usual vacuum, leading to lower pressure in the intake manifold for a given throttle position. The ECU sees this mismatch between throttle position and map readings and may trigger performance-related codes such as P0106, suggesting a map sensor fault when the sensor is actually fine. Hopefully, by following these diagnostic steps, you can now accurately determine whether a map sensor is faulty and what actions need to be taken to get you back on the road. And that covers all the steps required to diagnose a faulty map sensor and its associated fault codes. If you've completed these checks and suspect your ECU is faulty, then send it to us for a test and complete rebuild to ensure long-lasting functionality. We hope you enjoyed this video. If you found it helpful, don't forget to give it a like and subscribe for more automotive troubleshooting tips. Thanks for watching, and we'll see you next time.